Hello, this is Susan Poss, and I'm working in Chapter 4, which is the chapter on graphing and writing linear equations. This is section 4.1, and this is video number 2. The next thing I want to talk to you about here is how to take an equation, and you see the equation here is x plus 2y equals 8. How do you take that equation and find a series of points so that you could graph those points and get a straight line? So that's why they're called linear. When you graph these, you get your x-coordinate and your y-coordinate, you get a series of points, and the points should all be collinear, which means they all fall into the same straight line. So you've been given in part A here an x-coordinate of 0. You see that? And what we're going to try to do is find out the corresponding y value that goes with an x value of 0. So it's a fairly straightforward process. I'm going to copy down the equation. And in place of the x variable, I'm going to put in the value, which they gave me here was 0. Whoops, I said 0 and wrote 0, and I meant to write 8. Sorry. That leaves me with 2y equals 8, and dividing by 2, I get 4. So when x is 0, y is 4. All right, so let's move on to part B. I'll change the color so you can keep track of which work goes with which numbers. Here's the equation again. This time the number is sitting in the second position. That means that is the y-coordinate, and you and I are trying to figure out the corresponding x-coordinate. So I'm going to go into the equation, replace y with 3, do the solving process. I'm subtracting 6 from both sides, and I end up with a corresponding x value of 2. So when y is 3, x is 2. And the third time through, and generally you're going to want to get 3 points. 2 points is enough to determine a line, but the third point just verifies and helps you know that you're correct. So in this third point, item C, you can see that they have given you an x-coordinate. So I'm going to replace x with -4. So that gives me this little equation. If you remember all of our solving steps from chapter 2, I'm solving now for y, dividing by 2, and so when x has a value of 4, the corresponding y value is 5. Now what you and I will be doing eventually with this process is we will go on to a grid, and you'll see me do that shortly. We'll plot the point 0, 4. We'll plot the point 2, 3. And we'll plot the point -4, 5. Ooh, it's gonna kind of squeeze in there. I'm sorry, I kind of got things on top of each other. But what I wanted you to see is that these points should all be collinear. They should all fall into that same line. All right, so let's scroll down here and look at it in a different way. These are the same kinds of problems. You're given an x value, and you're supposed to be figuring out what the corresponding y value is, or you're given a y value, and you're supposed to be figuring out what the corresponding x value is. So the process is the same. It just looks a little different here because it's been put into a table. All right, so the first one I'm going to work with here is an x value of -2. So I'm going to take this equation, plug in for x with -2, do the arithmetic, and come up with a corresponding value of 8 when x is -2. All right, so again, I think I'll change color. This time, the y value is given to me, and I'm plugging in for y with a -12. And now I'm going to solve explicitly for the letter x. So I hope you see that I need to be dividing by this coefficient. Again, this is chapter 2. That produces the positive 1x, and over here on this side it produces a positive 3. So when y is negative 12, x is 3. And we'll do one more. This time the y value is 0. So I'm going to let y be 0. And again, I'm going to need to be dividing by that negative 4 coefficient to produce a positive 1x, and 0 divided by anything is 0. So that's the way you're going to work through these, filling in the chart, and then eventually we'll plot those points. I wanted to do one more that's got a fraction in it. And they have given me a value of negative 3 for x. Of course, you can use your calculator to help you multiply 1/3 times negative 3. And it looks like when x is negative 3, y is also negative 3. That happens sometimes. It's not unusual. All right, the second time through, the x value they have given me is 0. And anything multiplied by 0 is 0. And 0 minus 1 is negative 1. So when x is 0, y is negative 1. And let me change color one more time. The equation says 1/3 x minus 1. And in this last situation, they've given me the y value. So I need to add 1 to both sides. Again, this is chapter 2. And in order to get a lead coefficient there of positive 1 in front of that x, you can think of this a couple of ways. You can think of dividing by 1/3. I think probably most students would feel pretty comfortable about that. So that these are going to cancel out and give you the x. This part is called a complex fraction. So I'm going to write it out horizontally. 1 divided by 1/3 is the same as 1 times 3 over 1, which is 3. So when y was 0, the corresponding x value is 3. And very quickly I wanted to work just one that's got a little bit of an application to it. The graphing is very heavy into applications. If you've been watching anything at all about the coronavirus, which is going on right now, you've seen all kinds of graphs and models, and all, of course, all of that is mathematics running behind the scenes there. Right, so this gives us a formula for a volume, which is 6 times the height in cubic centimeters. And they're giving us various values for h. So the first time through, h is 4, and 6 times 4 gives us cubic centimeters, 24 cubic centimeters. The next time they give us an h value of 5, where h is the height. Of course, that's going to be a volume of 30 cubic centimeters. When they give us a height of 9, that gives us a volume of 56 cubic centimeters. And when they give us a height of 10, that gives us a volume of 60 cubic centimeters. And here's a grid down here. Let me scroll up just enough. The h value here is on the x-axis, and the v value, the volume, is on the y-axis. And you'll notice that this is just quadrant 1 that you're seeing. If I extended these lines back and down, this would be the origin, and you would see quadrant 2 back here. And down here you would see quadrant 3, and over here you would see quadrant 4. But this is only dealing with positive numbers, so that's why we're only looking at quadrant 1. So let me plot the first point. When the height is 4, the volume is 24. When the height is 5, the volume is 30. When the height is 9, the volume is 56. Sorry, I multiplied wrong. 9 times 6 is not 56. 9 times 6 is 54. And that works nicely on my graph. So 9 and 54 is right there. Glad I caught that. And 10 and 60. So a height of 10 gives us a volume of 60. And I hope you can see that this is what we would call a linear, let's see if I can get it to straighten out, a linear equation. And all of those things are following along. You might even call this a model, since you've been hearing a lot in the news about models. All right, so that's a good place to stop.